Hi, this is Alex from devstories.eu. Asyncio, episode 1 of 20. Many developers hear the word asynchronous and assume their code will execute in parallel across multiple CPU cores. But then they inspect their application and find it running entirely on a single thread. The secret to this efficiency without true parallelism is the event loop, and understanding its mental model is the foundation of Asyncio. The event loop is the central execution manager of any Asyncio application. It is exactly what the name implies, a continuous loop that checks for operations that are ready to run, executes them, and then looks for the next operation. It is vital to separate this concept from multithreading. In a multi-threaded program, the operating system controls execution. The OS will forcibly pause one thread and switch to another to share CPU time. The threads themselves have no control over when they are paused. This requires significant system overhead to manage the context switches and protect shared memory. The event loop operates on a completely different model called cooperative multitasking. Everything runs sequentially on one single thread. The loop never interrupts an operation. Instead, it relies on the code to explicitly yield control back to the loop when it has to wait for something. Think of the event loop as a single expert chef in a busy restaurant kitchen. The chef receives multiple orders at once. If they place a large pot of stock on the stove to simmer, they do not stand in front of the stove staring at the liquid until it finishes. That approach would block the entire kitchen and nothing else would get cooked. Instead, the chef starts the stove, leaves the pot to simmer, and immediately pivots to chopping vegetables for another dish. The chef represents the single thread of execution. The event loop is the chef continually scanning the kitchen, knowing exactly which pots are simmering, which pans need flipping, and moving instantly to the next available job. In your software, a simmering pot is usually an input or output operation. When your code sends a request to a database, the database takes time to process the query and send the data back. A traditional synchronous program would freeze and wait for the response. With an event loop, the operation registers its request and then tells the loop it is waiting. The event loop immediately switches to another piece of code that actually has data ready to process. When the database finally responds, the original operation signals the event loop that it is ready to resume. The event loop places it back into the queue and will resume executing it as soon as the current job yields. Here is the key insight. Because the event loop cannot forcefully stop an operation, the entire system relies entirely on cooperation. If one job decides to perform a massive mathematical calculation without ever yielding control, the event loop stops. The single thread is occupied. In our kitchen, this is the chef deciding to manually grind a massive bag of flour while ignoring every other dish. The simmering pots boil over, new orders pile up, and the kitchen grinds to a halt. The loop is only as efficient as the code running inside it. True asynchronous efficiency does not come from performing multiple calculations at the exact same physical moment, but from ensuring your single thread never wastes a single millisecond idling while waiting for the outside world. If you want to help keep the show going, you can support us by searching for Dev Stories EU on Patreon. Thanks for listening. Happy coding, everyone.